we are going into tools option. So if you just click on that tools option, you can see set configuration. So in the last edition of the software, they have reformatted this set configuration parameters. If you click on this, it is now representing in this manner. If you are having older versions of the PV lead, let's say PV 25, 24 or before that, you can see that the set configuration options were entirely different from right now what we are seeing. Okay. So they have made it as per the convenience. Let's say for nozzle options, they have kept it separately. ASME options are separately. Impact test options are separately. Earlier, it was all meshed together. Now, if you just click upon the job specific settings, so print water volume in gallons. So if you want the water or the liquid volume to be printed in gallons, then click on this checkbox. Round thickness to the nearest nominal size. So let's say when in a design, if you click upon this, you can see that down below over here, there is a help coming over there. If I click upon print, you can see this is related to print. If I click upon this round thickness to the nearest nominal size, the information is getting changed. So the round thickness to the nearest nominal size, if you click upon this, what is going to happen? When in design mode, it rounds the selected thickness to the nearest 1 by 16th inch or 1 millimeter. So we are going to always do the analyze option, that we are going to give the inputs and then the software is going to analyze whether we have selected the thing which is correct or not. We are not going to use the design options from the software because it does have a lot of limitations. Based upon the market availability, the software cannot choose what is available. So usually we are going with analyze option and not the design option. Then comes print equations and substitutions. If you uncheck this, so software will not print the equations. Let's say for shell thickness calculation, UG27, PR upon AC minus 0.6P is the equation. So the software will show you the equation and the values what has been substituted in that will also be shown. So this option always click on because we want that what the software has done, we should be knowing this. Print flange calculations for external pressure. If you are having internal and external pressure, and if you want the flange calculations for external pressure also to be printed, so click upon this checkbox. Okay. Use eigen solver. So this will be used for the seismic calculations. So always click upon this. If you just hover your mouse on the vertical line, you can see these two lines like this, right? I can press the left mouse button and then I can drag this so that whatever is been written over here, I can be able to see. So just hover it over here, then hold your mouse left button and then you can drag it here and here. Is it clear? So use nominal head thickness when computing the longitudinal stress. So this is also not required, but if your specification asks for, then only these options you have to click upon. Lap joint flanges are lines of support for external pressure. So if you are using any lap joint flanges, and if you want that to be considered as a line of support, so prior to that, what is external pressure? What is the concept of line of support that you must be knowing? So don't click upon this. Then no MDMT calculations. Minimum design metal temperature. And when we are talking about MDMT, that is minimum design metal temperature, I was referring to UG20. So you can see over here UG20. Here maximum design temperature and minimum design temperature. The clause B is about the minimum design temperature. And in that, if you just have a look at MDMT has been mentioned over here. And here they have written that the minimum metal temperature used in the design shall be the lowest expected in the service except when lower temperatures are being permitted. So because of your process, if any lower temperature is coming, that you need to consider. Then the consideration shall include the lowest operating temperature. Let's say your operating temperature is -10. So yes, that we have to consider. Then the operational upsets means what? Let's say the plant is running because of some reason, if it is suddenly stops. And because of that, if any temperature is coming which is lower, so that will also one of the contributor or one of the factor to be considered while defining MDMT. Then auto refrigeration. Let's say if you are having nitrogen service and because of the auto refrigeration there, locally the temperature can go on the minus side. So if that is the case, that factor also needs to be considered. Then the atmospheric temperatures. Let's say if we are having the plant running in Himalayas, so there will be very negative temperature which may be experienced, right? So that also could be one of the factor while deciding the MDMT, and any other source of cooling except as permitted in F3 below. So these are all the possible reasons because of which the temperature can be on the negative side or on the lower side. So because of this, any temperature is there, that is termed as a MDMT. So based upon the geometry, the code has also given that particular material can sustain till certain temperatures. So the code based upon the geometry selected, thickness selected, material of construction will tell us, rather the software also have the option. The software will tell us whatever geometry you have selected, that geometry along with MOC and the thicknesses, material of construction, can be used till what temperature. So let's say the software has analyzed and told you that this particular geometry and material can sustain -20 degrees Celsius. And if because of the process or because of the environment your requirement is -10, so it can sustain more than that, so it is safe. But if your requirement is -30 and the geometry what you have selected can sustain only -20, in that case, impact testing we need to perform. Is it clear? So that is the code requirement. So the software will not tell you that what is the code requirement. That must be known to you, isn't it? So this is about the MDMT. Then comes MAWP calculations. This is UG 27. This is a clause which will be used to calculate the thickness for cylindrical shell. Okay? Thickness of the shells under internal pressure. In that, if you go to C, UG 27C, that is for the cylindrical shells. Here you can see one equation, right? PR upon AC minus 0.6P. So by using this equation, you can choose the thickness. Let's take one example. Let's say if we have calculated the thickness by this equation and we have reached to 3.2 mm as the required thickness. But whether 3.2 mm is available in the market, let's say no, it is not available. The next available thickness is 4 millimeters. So what we are going to do? We are going to choose which thickness? 4 mm. How much was required? 3.2. So let's say earlier there was 10 bar pressure. How much? 10 bar. So 10 bar pressure was asking for 3.2 mm as the required thickness. But we have chosen 4 mm because it is available in the market. So tell me whether 4 mm will be able to sustain only 10 bar pressure or it can sustain more than 10 bar pressure. More than 10, right? So if you just alter this equation where P is unknown and the rest of the things are known. Let's say thickness is now known to me, which is 4 millimeters. So I can put that as an input and pressure will be unknown. E is your joint efficiency, R is the inside corroded radius, and T is the thickness what we have chosen. So based upon this equation, we will get certain pressure, correct? That is the maximum capacity of that particular thickness what we have chosen. That is called as MAP, maximum allowable pressure. So MAWP definition is that maximum allowable working pressure measure at the topmost position of the vessel, where from the static head we have to subtract. In MAWP, static head, we have to add to get this pressure. So as we have calculated this pressure, and let's say there is a 0.2 bar as a static head. So we have to subtract static head from this pressure. Now whatever answer comes, that is called as MAWP of that particular component. Are you getting me? Yes. In design pressure, if you look at the definition UG 21, it has been told that, or it has been written that we have to add static pressure in the design pressure. So the design pressure will be including the static head at that particular location. So whatever pressure we are going to calculate by this as a capacity, from that static head we have to subtract, and that term is called as MAWP of that particular component. Let's say the vessel is made up of dish end, shell, nozzle, flanges, multiple components, right? So every component will be having its own MAWP. So we have to compare all the MAWPs, and out of all, whatever is minimum, that will be termed as the MAWP for that entire vessel. Is it clear? We are talking about over here is asking whether you want to perform the MAWP calculations or you don't want to. So don't click on this. Always we want MAWP to be calculated, right? Is it clear? Use bolt load instead of bolt area times the bolt stress. So this is called as a pull bolt load. So don't click on this. There is another option from where also you can start it. External length L includes the flange thickness. External length means what? The length which will be used in the external pressure calculation. This L is called as the length between the line of support. So the thickness of the flange should also be included. Keep on this as a checkbox. Always open. Then add moments at the lug support due to the seismic loads. When you are going to calculate the stresses at the support lug, and if you also want to add the moment at the support lug locations because of seismic load, then click upon this checkbox. Is it clear? So where is the compressive allowable for the internal and external cases? When calculating the compressive allowable stresses for the vertical vessels, this option will compute the compressive allowable for each case involving the IP and EP. IP means internal pressure, EP means external pressure. Separately, based on the internal or external loadings. So these are the by default option. Usually don't change this unless and until you require any specific requirement. That point of time, I'll let you know that which option to be click upon. Okay. So by default, whatever the options are there, usually do not change that. Is it clear? Show only unfactored loads in the vessel summary. So when we are going to see the vessel summary for the loads, you will come to know what is the unfactored load, what is the factored load. And in that case, if you don't want the unfactored loads to be printed, then click upon this checkbox. Okay. So right now, whatever options we are seeing, when you are actually having one live example and when that particular case will be applicable, then you will better correlate with that. Right now, I'm just showing you that on job specific settings, these are the options, right? Allowable tower deflection, inch per 100 feet. So as per ASCE, American Society of Civil Engineers, the allowable deflection is 6 inch per 100 feet. Okay. So this 6 inch per 100 feet is by default. This is as per ASCE. But if you are using any other code, if you want that to change, instead of 6 inch, there is 8 inch which has been mentioned over there. So you can change that particular thing from here. Wind shape factor. So when the wind diameter will be getting multiplied with the wind shape factor, if you want, you can set that. Otherwise, the software will take it from the code itself. So whatever options it is being shown over here, these are to be kept as it is. If at all it is required to be changed, then at that particular point, I will let you know. So under job specification, you can see these options, right? Operating natural frequency. If you want to put some values, you can put it over here. By default, we are not putting any values. The software will automatically calculate it at the later stage of the calculation. So we are not changing this value ever, right? Then comes input echo. So whatever inputs you are going to give, can you see over here? Element type, diameter basis, blind flanges, overall flange length. That is in English. So these are the options available. So if let's say give Portuguese. So whenever that input options will be given, so accordingly that options will be in that particular language. So we'll always be having it as English. No bill of material. So whenever we are going to have the software run for, so there will be a page called as bill of material. If you don't want that to be printed, so you can click upon this no bill of material option. So let me just run this. So don't bother about whatever warnings are coming. So that anyway we are going to discuss in actual modeling stage. Here what we are seeing, what is that bill of material? Can you see over here bill of material? So this is the bill of material which will be by default printed by the software. Okay. So if you don't want that to be printed, then you can go to set configuration, job specific options, and then no bill of material, right? And now if I click upon the analyze option over here, can you see from here that bill of material option has been gone? No earthquake deflection calculations. So if you want earthquake deflection calculations to be printed, you can uncheck this. By default, wind deflections is what we are more concerned about, and that will be used. If you also want the earthquake deflection calculations are to be performed, so you can click upon this checkbox and it should be unchecked. Okay. Use smaller of attached shell and small end hub. Use smaller of attached shell and small end hub thickness for G0. Select to use the smaller of the attached shell and small end hub thickness for G0. So when we are going to have a weld neck flange, so welding neck flange will be having a smaller end hub thickness. In this portion is called as G0, small end hub thickness. This portion is called as small end of the flange, and this is called as the large end of the flange hub. This is hub, this is small end hub, this is large end hub. Okay. So use smaller of the attached shell. Means what? If let's say I am going to have the shell after this will be welded with the nozzle neck. Are you getting? So let's say this is the hub, and after that there will be a shell like this. So amongst these two, whatever is minimum, that should be used as G0. That is what it has been asked. Select to use the smaller of the attached shell. This is attached shell. And the small end hub thickness for G0. This is small end hub thickness, right? So among these two, whatever is minimum, that will be considered as the G0.
Okay.
Consider nozzle loads on the supports. If you want the nozzle loads to be transferred to the supports, means what? This is not always the requirement. Many a times the Gulf countries will ask for it. the vessels if these are let's say this is your vessel. Okay. Can you see this?
Yes.
And let's say this is the skirt support. Now, if there are some forces like this, let's say there is 100 kg force which will be created by the piping at the disc end. So right now the software does what? Software performs the local load analysis at this junction caused by this nozzle and see if this junction is safe or not. But if let's say if this is acting in downward direction, so it is going to push the vessel down, correct? So if it is going to push the vessel down, it will add the load at the foundation. It will also going to push the foundation down. So if you want the nozzle loads to be considered in the foundation calculations, then you have to click upon that checkbox. Many times in Gulf countries, the soil is very soft at the bottom, and because of these nozzles, if there are any additional forces are coming, so in Indian conditions this will be very easily absorbed by the foundation, there won't be any problem. But if it is very what we can say soft soil over there, and if because of this the foundation may deform, isn't it? So for that purpose, if it is Aramco job or any other jobs in the Gulf, they will ask that the nozzle loads to be transferred to the supports. If it is been asked, then you have to click upon this checkbox. So what is going to happen? It will transfer the loads onto the foundation. Here there is a percentage that you can give, that how much percentage you want to be considered in the foundation. So usually it is 100%. Is it clear? In normal calculations, we are not clicking on this. But if your specification asks that the nozzle loads to be transferred to the foundation, then we have to click upon this checkbox. So here, syntax highlighting in output report. The output reports what we have seen. So let's say here, if I type external, can you see this yellow color? This is called as a syntax highlighting. Syntax highlighted in the output report. Extended ASC
Ready.
characters in output. So these are
Mm.
the options.
Now,
What has been given as default, we are keeping it as it is, and whenever any specific is required, then only we are changing that. No extended ASC double I characters in output. Select to only use the characters in ASC II table. So if that is ASC II is what your standard to be followed, then only you have to click on that. This is not for all. Metric output is in consistent units. Always we are having the output in consistent unit. You don't have to click upon this. Select to make sure that your metric output is displayed in consistent unit. If you want to have metric unit always, you can click on this. If you want to have metric input to imperial output, means what? You are putting the data while modeling in millimeters and the answers in the report what you want in inches. So the metric is input and imperial is output. If you want to have that, then you have to click upon this checkbox. Okay. So usually we want metric input, metric output. Metric constant selection. So determine at runtime means what? The software at a runtime will convert, let's say, mm into inches. So divide it by 25.4. So determine at runtime, that is what we are always keeping.